Okay, so next here we have the test 3G, the last numerical test for chapter 3, okay, science, class 9, uh, atoms and molecules. So question is includes these questions, so you can write it down and come back and join here. Question number 8, textbook, you'll find on page 46. I've even written the question here, convert into mole. The first one, A, 12 grams of oxygen gas. Okay, so now before we go and proceed to this, we know that we have to remember this general formula. So let us just remind ourselves here. 1 mole is equal to the gram, okay, is equal to, let's write in capital then, gram. If it is atom, then atomic, or if it is molecule, then molecular, gram molecular mass. And we know this is equal to the Avogadro number, 6.022 into 10 to the power 23 atoms if it is atoms, and molecules if it is molecules. So we need to absolutely know this formula because everything is going to be based on this formula. And if we know the mango method that we started with the first video, the 3D, we're going to follow that mango method and then this formula, right? So here the question said convert mole into mole, 12 gram of oxygen. Now, if I say like this, rupees 100, what is this? Yes, you will say this is money. Likewise, if we say gram, then even if they didn't tell us, we know this is mass. Because gram is a unit of mass, just like rupees is a unit of money. So this is mass and this is mole. So we have to use these two parts of formula, mole and mass. Not this one. This is the number of atoms. So we're not going to use a number this time. So here, the A answer, okay. Now this formula you need not write like this. This is just kept here so we all can see and help us to solve. Right here, you have to calculate the mole. So let us keep that on the right side. Usually that's easier for us, right? To keep the one we want to find on the right side. Though that's not a hard and fast rule, right? So let us start with this one. We know this one, gram, as you can see here, gram. Now in this question, it's interesting because they did not give us the formula, just wrote their oxygen gas. So the question expects us to know the formula ourselves by now. That is why your worksheets, the starter, 1 double plus, those are quite important. Only then you can know the formulas yourself, especially when the question is not giving you the formula like this, right? So gram, now oxygen gas is molecule or atom, that's the problem. Now I'll just write it and explain it. Gram, it's molecule, okay, molecular mass. I'll just explain why. Of, I'll just write this one, oxygen gas, of oxygen gas. Why we wrote molecule is because oxygen formula or oxygen gas is same. It's not O or 2. That's why I wrote here molecular, because anything more than one atom, here you see here 2 oxygen atoms making the gas. So more than one atom, so it's a molecule. So gram molecular mass of oxygen gas is equal to 1 mole, because the formula tells us that gram mass is always equal to 1 mole. So let us extend this and just calculate a gram mass from here itself, in the first step itself. So here, that is, at the back of the oxygen gas formula, there are 2 means there's 2 oxygen atoms. And on page 37 of your text, 1 oxygen is 16U. But here we have to write gram. So we write there G, and 16 to the 32 grams is the gram molecular mass of oxygen gas. So 32 gram, in other words, is making 1 mole, right? So let us find it out for 1 gram of, okay, oxygen gas, O2. You can just write it in short now. It's equal to this 1 divided by the 32. The mango method, right? So here, on the unit on the right side is mole, so we write here mole. When we bring the 32, we shouldn't bring the gram. As we have been telling again and again, the unit that is on the left, gram, cannot be brought on the right side. So also the unit mole, which is on the right side, will remain there permanently, cannot be brought to the other side, okay? So to avoid confusion, keep that in mind. Now they are asking not for 1 gram, but 12 grams. So let us find out 12 gram of oxygen gas molecule will therefore be 1 by 32, this one we write the same mole. And then we multiply by this 12, like the mango method. But as we said, we shouldn't bring the unit gram on the left to the right. So here 4 3s are 12, then 4 8s are 32, right? Then so we're getting here an answer of 3 by 8 mole. So that is your answer. But we usually do not write answers in this form, so let us divide. And if we divide this, 3 is divided by 8. Notice that numerator is smaller. So smaller than divisor means 0 point, then here 0. 8 3s are 24, then 6 remain. Point means I can put 1 0 here, right? And so 8 7s are 56, then here 4 remain. And dot means here 0 again, and 8 5s are 40. So we can write our answer as equal to 0.375 mole. That's the preferred form of answering. And don't take approximation to second place because here no remainder, you see. This is an accurate answer, so we would prefer to keep it like this. Now this can also be your answer, but then this is the preferred form of answering, okay? So that's the first one. So let us go to B now. So let me just write here. This is our formula that we could use in every sum in this question 8. Now B, let us go to the textbook and see. There it says 4 moles, no sorry, 20 gram of water. B is 20 gram of water. Again, they did not give us the formula of water. They expect us to know this. So again, you have to convert the gram means mass. Again, mass and mole. See, so same method. Here, gram. Again, we write molecular because water is a molecule. Molecular mass of water, and we are expected to know the formula H2O. That's why there are here 2 hydrogen atoms, 1 oxygen atom equal to 3 atoms making the water. That's why it's molecule, more than 1 atom, right? So now we write that, okay, and there let us calculate it here itself. That is here at the back, the number of atoms for each. The number of atoms for each of the atoms will be the subscript. Subscript means backside. The subscript 2 will belong to the front one, not to the back. So 2 hydrogen atom is there. Multiply to page 37, 1 hydrogen is 1, the mass, plus going to new atom means we put plus. At the back of all, no number means 1 oxygen atom, and 1 oxygen atom is 16. So we close the bracket and we write here G commonly because it's gram molecular mass, sorry. So that will be equal to, okay, so here, okay, let's just do like this. That will be equal to 2 1s are 2, 1 into 16, 16 plus 2, 18 grams is the gram molecular mass of water, which will be always equal to gram molecular mass always equal to 1 mole. Even though that question did not tell us, we know that we have to use the mass and the mole because gram is mass and mole is given in the question, right? So here now, if 18 grams, in other words, 18 grams of water make 1 mole. Therefore, 1 gram of water, we can just write the formula from now on. 1 divided by 18 and mole, the unit on the right side. We shouldn't bring the gram. Left unit should not be brought. As we have been saying. So 20 gram, they're asking for that, of water will be therefore 1 by 18 mole. And then multiply to this 20 we get here. So almost getting the answer. So 2 9s are 18 and 2 10s are 20. So your answer is 10 divided by 9 mole. But we can write this answer form in so many different forms, up to you now. 10 is now divided by 9. 9 1s are 9, 1 remainder. No more digit. So one way of writing your answer is 1 here, quotient divided by remainder divided by down here divisor. This is also right way of answering. Or you can go continue and write in this form also. Then put a point, then 0. 9 1s are 9. Textbook answer is given in this way. 9 1s are 9. Okay, let's just shorten it. 1 2 3. Then again 1 remainder, go up to third place. This is what textbook is doing. 9 1s are 1 2 3 4. 1 2 3 4. So stop there. Then your answer is 1.111 mole and final answer, like the textbook style, means 1.11 because third place is less than 5. Usually the second place is the most common way of answering. So you can write like this also, but this is how the textbook is doing. 1.11 mole approximately. Then here C, let us go to C. C is 22 gram of carbon dioxide. Again, they did not give us the formula. They wrote the name only. So they expect us to know these common formulas. That's why your worksheet starter, worksheet 1, 1 plus, 1 double plus is so important, because if you do that sincerely, then you will be able to write these formulas without problem. Again, gram, mass, and mole. So this same formula. So here, gram, again, I will write molecular mass of carbon dioxide. Carbon dioxide. Why did we do that? Because carbon dioxide formula is CO2. That's why. So now let us find the gram mass here itself. That is 1 carbon. So 1 into 12 plus 2 oxygen into 16. This much is equal to 16 twos are. So we can just proceed down here. That is 12 plus 16 twos are 32. So that is equal to 44 gram is the gram molecular mass of carbon dioxide. Okay, here 1 carbon, 2 into 16 oxygen, because oxygen is 16. So this 44 gram of carbon dioxide is always making 1 mole, because gram mass always equal to 1 mole. Therefore, next step you can proceed. Therefore, 1 gram of carbon dioxide will be this 1 divided by 44, and the right side you need is mole. We shouldn't bring the G, and you know why. So therefore, they're asking us for here 22 grams. So you write your 22 gram of carbon dioxide will therefore make how many moles? 1 by 44 mole. This same one multiply to this 22. And don't bring the G again. 22 twos are 44. So this is half mole. And half mole is nothing but, it's quite easy to divide, I think. Many people know even without dividing, this is 0.10, 2 fives are. So that is equal to 0.5 mole exactly. Okay, 0.5 mole exactly. So that is your answer. Now we've done the 8, so we'll go to the 17, then 18. So let us just keep this formula in front of us again, because we may need it again. So here, that's this one. This is done. And let us go to question number 17. Textbook, page 47, you'll find. Okay, let us read the question. 17. Calculate the number of molecules of sulfur in bracket S8 present in 16 gram of solid sulfur. Okay, let me write the question also so we can all see it very clearly. Calculate, okay, the number of molecules, not mole, okay, molecules, number of molecules of sulfur. Please follow closely. Sulfur formula is S8. So there are 8 sulfur atoms. So this is definitely a molecule. More than 1 atom, molecule. There are 8 atoms now present. Okay, present in 16 gram of solid. 16 gram of solid sulfur. This is exactly how the textbook question is on page 47. So let us just follow it closely and do slowly. It's quite easy. Present in 16 gram. Now here, calculate the number of molecules, means this one, see, number of molecules. So we have to use this time this one, number of molecules of sulfur S8 present in 16 grams. So they're using gram, means just like rupees means money, gram means mass. So we have to use this mass and number this time. We should not use the mole, very clearly. So the question is not telling us, but we are expected to know which two part of the formula we're going to use by reading question very clearly. Number of molecules here and gram here. So a mole should not be involved. So here, just right here, you have to calculate the number of molecules. So we'll put these molecules on right side. So gram, we'll put on the left side. So gram molecular mass of, okay, S sulfur, which is in bracket S8 very clearly given. That is how much? 8 sulfur. Now go to page 37 of the textbook and tell me how much is 1 sulfur atom mass. Yes, 32. So we put G because it's here gram. So that will be equal to how much? 8 2s are 16, 8 3s are 24 plus 1 25. 256 gram is the gram molecular mass, because there's more than one atom, you see. 8 S8 means like this, sulfur 8. So more than one atom molecule is equal to, we're going to have to use the number of molecules. So 6.022 into 10 to the power 23. We will write molecules because this is clearly molecules. So we know the gram mass is equal to Avogadro number of molecules, 6.022, 10 to the power 23, or gram mass is also equal to 1 mole. But this time we're not using mole, we're using the number of molecules. So this one here is, we are bringing out from the formula. So this should not be, this is not hard. Now next, we have to find out for 1 gram. So 1 gram of S8, right in short, 256 is this much. So 1 gram will be just like the mango method, you remember, 6.022 into 10 to the power 23 divided by this one, 256. Like we said, we should not bring the left side unit gram to the right side. The right side unit is very clearly number of molecules. So we write that, okay? Therefore, the question is asking us for 16 gram of sulfur. So we write here 16 gram of S8 will be 6.022 10 to the power 23 divided by 256. Let's write the same thing, molecules. And we bring the new number, multiply 16 that side without the gram. Okay, we should not bring the gram left side unit. Now 8 is going, I think 8 3s are 24, 1 in hand, 8 2s are 16, 8 2s are 16, and then 2 1s are 2, 1s are 2, 1 in hand, 2 6 are 12. Again 4 is going, I think, so let us cancel this. 4 4s are 16, and here 4 1s are 4. 6 is there, 2 remainder. So point and 2 will go in front of the 0. 4 5s are 20, no remainder. Then we should not take 2 digits at a time when you're cancelling. So just take the next number 2, but it is smaller than the divisor 4 we're using. So you have to put here 0 first. Then only these 2 can combine with the next one. So 22. 4 5s are 20. 21, 22, 2 remainder again. That because of the point, 0 will go behind the 2 remainder, 20. 4 5s are 20. So 1.5055. Okay. So that is the cancellation up to now. So this is 256 to avoid confusion. Now again 4 will surely go, so just continue doing. 4 1s are 4. Then here 4 0 point, because 1 is less than 4 we are using. Then go behind the decimal, 15. 4 3s are 12. Okay, 4 3s are 12. 15 is there, so remainder 13, 14, 15, 3 remainder 30. 4 7s are 28, 29, 30, 2 remainder. So 2 will go in front of this 5, 25. 4 6 are 24, 1 in hand. Again, then 1 go in front of the next 5, 15. 4 3s are 12, just do patiently. 13, 14, 15, 3 in hand, 30. So 4 7s are 28, 29, 30, 2 remainder. Because of that point, 0 will go behind the 2, 24, finally 5s are 20. That's why we're doing, because we know any number is going to go by 4 exactly. So 0.376375 is what we got. This is 10 to the power 23. So our next step here we're going to write equal to, just write the same thing so we'll have no confusion. 376375 into 10 to the power 23. We have here molecules. This is our answer. Nothing wrong, but then usually answers are given in standard form. What do you mean by standard form? Standard form means this decimal point come after the first digit, after 3. It means between 3 and 7. So if you do that 3 point, listen carefully, 7, then 6, 3, this is called standard form. decimal after the first digit. This is not standard form. So when you bring like that, no, in order to do that, you have to divide by this number by 10, because if you divide by 10 only, this will shift back and then become the original number. So this is 3.76375 divided by 10, and this number are same. So you divide, decimal move left again now. So if you do that, then here this one is 10 to the power 23 molecules. Okay, molecules. Now once you do that here, next step is here 10 to the power 1 gone. Here power is 23, so 23 minus 1 power is 22. So your answer is 3 point, and usually your answer is up to second place of decimal. How do you mean? Means we look at the third place, which is 3. After decimal 1, 2, 3, 4, 5 places are there. Usually answers are given in second place by looking at third place. Third place is 3, which is less than 5. So if it is less than 5, it will remain same. So 3.76. If this was 5 or more than 5, this would have become 6, would have increased by 1, 7. But since this is smaller than 5, third place, then we write here 10 to the power 22 molecules. So this is your answer. The most common way of writing answer is up to second place like this, by taking approximation from the third place. Okay, so 3.76 into 10 to the power 22 molecules. Replay the video here again if you need to. We shifted here, that's why we needed to divide by 10, otherwise this equal will become not equal. No? So divided by 10, then decimal, if you divide, then you'll go back to original. So that's why, and then 10 cancel here, because we wanted to make it standard form. Okay, so now that's your answer. The last step, 17. One more question for this before this test ends, that is 18. Okay, so we'll go to 18 again. Let us write down here 1 mole is equal to gram atomic or molecular mass. Atomic or molecular mass. Okay, gram atomic or molecular mass, and this is equal to Avogadro number 6.022 into 10 to the power 23 atoms if it is atoms, and then molecules if it is molecules. As I said, as we are ending, let us repeat this one again, that this formula is absolutely important in this chapter. 70-80% of the numericals are based on this. So if you know this, we'll have no problem. Okay, so now go to the last question, question number 18. This you will find on textbook page 47 again. Important sum. So you will find this on textbook page 47. Let me read the question. Calculate the number of aluminium ions present in 0.051 gram of aluminium oxide. Number of ions and atoms. Actually, ions and atoms are of same mass. Even in the hint, you see that the mass of an ion is the same as that of an atom. So number of ions means actually we find number of atoms is enough. So number and then again mass we're going to use. Gram is given as 0.051 gram means mass. Number of ions means this one, atoms only. So we should not use mole again. So here, let us start. So we're going to keep the number of atoms this side. So gram molecular. We will write molecular because aluminium oxide is definitely a molecule. Molecular mass of aluminium oxide. Now for those of you who know the starter properly, you can write the formula yourself. I think the textbook did not give us the formula. See, that is the problem. So in that case, you'll get stuck if you don't know the starter. And also Al3 plus O2 oxide is O2 minus. So you write here Al3 plus, don't write there, keep in your imagination. 2 minus, oxide is 2 minus. 2 and 3 can cancel, so this 2 will go at the back of Al, 3 will go. So this is how we can make the formula if you know your starter. That's why knowing your starter, worksheet 1 plus, 1 double plus is so important, because in some questions in your text, they're not giving formula. It means they expect you to know, to make the formula yourself. How will you make this formula if you don't know the starter? And if you don't know this formula, then how will you calculate? It's impossible, right? So now I hope you're getting it. Now, gram is equal to this one, 6.022 into 10 to the power 23 atoms. Not atoms, sorry, in this case, it is molecules, aluminium oxide molecules. sorry, here, see. 2 aluminum atom, 3 oxygen atom means there are 5 atoms, means more than 1 atom, that's why molecular mass. Okay, now let us calculate the gram mass here. That is 2 into aluminum is 27 plus 3 new atoms will go plus here. 3 into 1 oxygen is 16. Okay, that's much grams. You will find this on page 37. Aluminum is not given, I think, on page 37, but it is given here in the question number 18 at the back. See, 27 U. We changed that to G because we have written here gram mass. So that will be equal to 54. 2 into 57 is 54, and 3 into 16 is 48 grams, and this will be 100, and okay, 102, 102 gram is the gram molecular mass of aluminum oxide. So let us find for 1 gram. 1 gram of aluminum Al2O3 will therefore be this one here, 6.022 into 10 to the power 23 divided by this one, 102, and the right side you need is molecules. We should not bring this gram left, you need to the right. Okay, therefore they are asking for 0.051 gram of aluminum oxide. Look into your question. Calculate the number of aluminum ions present in 0.051 gram of aluminum oxide. So this is the mass they're asking us to calculate. So 6.022 into 10 to the power 23 by 102 molecules. Just write the same thing as it is and multiply that to this number, 0.051. Don't bring the gram to the right side. Okay, now see here, I think 2 is going with this. This will make it easy for you. 2 3s are 6, right? 2 3s are 6. So write that 2 3s are 6 point, and then 2 zeros are 0, 2 1s are 2, 2 1s are 2 up to here. Similarly, 2 5s are 10. No in hand, 2 1s are 2. So that makes it easy for us here. 51 we got here. Now 51 1s are 51. Use the same is going here, you see. 51 zeros are 0. 51 you are using timetable of 51. 51 zeros are 0. No in hand. Then we, while cancelling, as we have been saying, we cannot take double digit at a time. Only the single first 5. 5 is less than 51, the timetable we are using. So we need to put 0 first. Then only the 5 will combine with the next one, 51. Now 51 1s are 51. Replay the video if you are getting confused. Okay, so now next, let us do this part. 3.011 here after cancelling, and then okay, let me write it once more. 3.011 for this into 10 to the power 23 molecules. Just same thing into, now you see here 0.1 means 1 divided by 10. Nah? 0.01 is 1 divided by 100. Okay, like that. So this is 1 2 3 means 1 divided by 1000, because there are 3. So 0.001 will be just like that, triple, right? So 10 to the power 3, this one. So 3 is gone. 23 minus 3 power, only 20 power is left. This is power, okay, not number cancellation. So your answer is 3.011 into 10 to the power 20. Okay, 10 to the power 20 molecules of aluminum oxide are there in 0.051 gram of aluminum oxide. But they're asking us the number of aluminum ions. Now, so we have to write like this. Now, okay, you see here. So this one, molecules. So one molecule of Al2O3 contains equal to how many aluminum atoms at the back? 2, yes. So we write here 2 aluminum atoms, right? So one molecule contains 2 aluminum atoms, as you can see from here. 2 aluminum atoms and 3 oxygen atoms. Therefore, the total number of molecules in 0.051 is so many. So we write that one. So 3.011 into 10 to the power 20 molecules. One molecule, very easy, we got it. 2 aluminum atoms are there, you see. So this many molecules of Al2O3 will contain, here 1 molecule 2 means this one will be, these aluminum atoms write the same thing multiplied to this number 3.011 into 10 to the power 20. And we should not bring molecule, the left side unit should not be brought to the right side. So which is nothing but equal to 2, don't multiply this, 2 here, 2 ones are 2, 2 ones are 2, okay, 2 ones are 2, 2 ones are 2, 2 zeros are 0, 2 threes are. So when you multiply this to this, you get this one. Into here, 10 to the power 20 aluminum atoms, right? So that is your answer. But before you write the final answer, you see here, but look at the last part. Mass of an ion, the mass of an ion, the mass of an ion is, textbook there, the same as okay, the that of an atom, that, okay, that of an atom. The question is saying that to us. So this much molecules of aluminum oxide contains this much aluminum atoms, so it will be the same number of aluminum ions also, because they are saying ion and atom are same mass. So we write here therefore 3.011 into 10 to the power 20, let's write the same statement, molecules of Al2O3 will contain equal to, I have to put not as contain because it's plural here, this side is plural, contain, okay, same number, 6.022 into 10 to the power 20 aluminum ions, because ions, atoms are same. So whatever you calculate for atoms, that number will also be true for the ions, because they are same in mass, same as that of an atom, their mass are same. So the answer, so this is the final way of writing, we should write ions like that. So that is your answer. This concludes your portion. Now go and give test 3G. Okay.